Hey folks, so what I have here is a problem from the 2021 Putnam exam. This is problem number 1 from session A. And it says the following. It says a grasshopper starts at the origin in the coordinate plane and makes a sequence of hops. Every hop has to have length 5, and after each hop, the grasshopper is at a point whose coordinates are both integers, so either positive or negative counting numbers. Thus, there are 12 possible locations for the grasshopper after the first hop. What is the smallest number of hops needed for the grasshopper to reach the point 2021, 2021? So a lot of times the exam will embed in the problem the number equivalent to what year it is. So since this was the 2021 exam, they put that number in the problem. Okay, let's go ahead and get started. So this is a standard coordinate plane. And the idea here is the grasshopper is starting at some origin, which we'll call 0, 0. And every hop that it makes has to have two conditions. So number 1, the length of said hop must equal 5. And the second condition is that it reaches, the second condition is that the location, so that x comma y, after each hop is such that x and y are integers. So we say that x and y belong to the set of all integers. And the goal is, we're eventually going to reach the point 2021, 2021. Don't know why I put those extra commas in, but there we go. Now, this is actually an amazing problem for the simple reason that all you need to solve it is some basic intuition and some high school geometry. Okay, so let's just play around with this idea. So let's suppose that I wanted to move, I don't know, say at some random point, 1, 2, 3, 1, 2. Right? You might think that 2, 3 has a distance of 5. How do we actually find the distance of a line segment? Well, we use the Pythagorean theorem, right? So if we drop this down, we have a right triangle with side lengths of 2 and 3. And then the Pythagorean theorem says that this distance squared is equal to the sum of the squares of these two legs. So then x would just be the square root of 13, which is not equal to 5. Thus, this is not a valid hop. So if all we're looking for is right triangles whose hypotenuse is 5, there should be one thing that screams out to you: Pythagorean triples. Okay, so a Pythagorean triple is a set of 3 integers, specifically 3 natural numbers, that form a right triangle. So the most common one is a 3, 4, 5 right triangle. The next most common one is a 5, 12, 13, and you can prove that there are an infinite number of those. I might do that in a separate video. But the idea here is that we want to get to this point, 2021, 2021, in the shortest amount of time possible. So the first thought is, well, the shortest distance between 2 points is a line, right? So why don't we just make hops along the line? And the answer is, well, that may seem like a good idea in theory, but let's just test this out for a second. So if that's the shortest distance, let's make our first hop, and let's suppose that it has a distance of 5. Okay, so I'm telling you that this has a length of 5. Okay, but if you drop this leg down, you know that by the Pythagorean theorem, this lies along the line y equals x, right? Because 0, 0, and 2021, 2021, those both have the same output as input, which means this is the line y equals x. So whatever the length of this right triangle is, the height has to be the exact same. So solving this right triangle is nothing other than solving the following. So we're going to be solving this guy, where both have side lengths of x, and that the hypotenuse is of 5. Now, if you know that this is a 45, 45, 90 triangle, that's another way to go, but I'm just going to do it this way. Okay, so x is going to end up being something like the square root of 25 halves, which is not an integer. And the x and y coordinates must be integers. So it's actually impossible to just straight up go distances of 5. So unfortunately, that's not possible. So now you have to start thinking, well, is there a way that I can kind of get as close to that line as possible and land on integers? And the answer is yes, by using the idea of Pythagorean triples. So if I wanted to form a 3, 4, 5 right triangle, the length would be 5, and that means I would end on x, y coordinates that are either 3 or 4 respectively. So either 3, 4 or 4, 3. So without loss of generality, let's assume that it's 3, 4. Now, this is not on my line, on my shortest path, but, I'm sorry, 4, 3, it doesn't really matter. But this is 4, 3. And this hop does have a distance of 5. Okay, so I'll draw that in, and we'll just highlight that in a different color. But then because of symmetry, what I can do is I can now form another 3, 4, 5 triangle, but this time, let's actually make it, a 4, 3, 5 triangle, which is the same because the Pythagorean theorem is symmetric with respect to addition. So 4 squared plus 3 squared is also equal to 5 squared. But this time, if I have coordinates of, we used 4, 3 for the first one, so we're going to use 3, 4 for the next one. We're going to move 3 units along the x-axis, and now 4 units along the y-axis. Okay, which means we're going to end up, you can already see it, but we are going to end up on this line. And what are the coordinates of this point right here? Well, the coordinates are simply 7, 7. Right? I don't know why it's not letting me erase. There we go. So we're not quite at 2021, 2021, but we are at 7, 7. Now the question you should ask yourself is, are there any other shorter hops that will get me a substantial amount of distance? And the answer is no, because Pythagorean triples go in order. So the next Pythagorean triple would be 5, 12, 13, but the distance 13 is unachievable in an integer number of hops. Okay, so this would be unrealistic. So 3, 4, 5 is really the best way to go. Okay, well that's great. So what I learned from this, so to summarize, to get to the point 7, 7, I need 2 hops. But can't I just keep doing that over and over again to get to 2021? So if I start at the origin, I can make a series of hops, right? I can go 3, 4, so plus 3 plus 4. So I'm adding 3 to the x-coordinate, adding 4 to the y-coordinate. And then I add 4, add 3 to get to 7, 7. Okay, but I don't have to write this every time, so I'm actually just going to kind of split the middleman and just say, I'm going to go directly from 0, 0 to 7, 7, and we all know that that takes 2 hops. Likewise, I can go from 7, 7 to 14, 14, and that will take another 2 hops. So the question is, can I keep doing this until I get to my point 2021, 2021? And the answer is actually almost. In order to get to 2021, 2021 in an integral number of hops, that means that the number 2021 has to be divisible by 7. Okay, but a quick computation will show that it's not divisible by 2021, and because this computation is going to be important, let's go ahead and just do it. So if I divide this into 7, what I get is, well, 2, 8 gets me 56. We're subtracting these. It's probably been a while since you've seen someone pull out long division, but there we go, 8. Okay, so what we got was, well, 288 doesn't quite cut it. All right. If I go 288 hops, that would get me to 2016. But I'm still 5 away from my goal, 2021. But the problem is, 5 is a kind of a dumb number because I only know how to hop in units of 7. So there doesn't appear to be a way to go 5 units. But actually there is. We just haven't thought of it yet. So for bookkeeping purposes, we know that 288 hops, or I'm sorry, 288 iterations of 2, right? Because we have to add 3 to the x-coordinate, add 4 to the y-coordinate, and then add 4, and then add 3. So this actually takes 576 hops to get to the point 2016. All right, so now my new picture is going to look like this. I'm so close, right? And I want some way to get to 2021. And I'm trying to figure that out. So far, again, bookkeeping purposes, I am at 576 hops. And I just have to figure out how many more hops will it take us to get to 2021. And the answer is very simple. So why don't you pause the video and see if you can kind of go from here. So if I'm at 2016, and I want to make some number of hops to get to here. So how many hops do you think that would take? Pause the video and try it out. Okay, so if you think about it, this distance right here, I don't necessarily know what it is right now, but I do know that in order to get to here, if I just draw my right triangle, that will essentially answer my question. So again, we've been using right triangles this entire video. So the x-coordinate has to increase by 5, and the y-coordinate also has to increase by 5. But if each hop has to have a distance of 5, and we know that the distance along a one-dimensional line segment, that is horizontal or vertical, is just simply the number of units. And since this is 5 units, hopping from this coordinate to this coordinate, which is technically 2021, that'll take a hop. And then if I'm here, this distance has to be the same because we're along the line y equals x. So this hop will take us to our end goal of 2021. So since that was 2 additional hops, our final answer would be the 576 it took us to get to 2016 plus 2 for a solution of 578 hops.